Question 2a. The diagram below shows part of a circuit containing 2 light bulbs and 2 resistors with a 10-volt power supply. A. State what is meant by the label 8 volts, 0.6 watts on bulb A. Well, I suppose to answer that question we've got to know, well, what does 8 volts mean and what does 0.6 watts mean? If we look at our formula sheet, we can see that a volt is defined as the amount of energy per charge, and power is defined as energy per time. So 8 volts, 0.6 watts means that when 8 volts is applied across this light bulb, the light bulb uses 0.6 joules of energy every second. So how would we get that? Well, V is the amount of energy per coulomb, and power is the amount of energy used per time period. If I was to rearrange this formula, I'd get EP equals power times time, and then I could stick this equation up into there. So I could replace EP with power times time. Voltage equals power time per charge, which becomes 8 volts equals 0.6 watts. And if we say the time is 1 second and the amount of charge is 1 coulomb, then when 8 volts is applied across this light bulb, you get 0.6 joules of energy. Because if we see this, this power times time is still energy. So we're using 0.6 joules of energy in 1 second. Or more formally, when 8 volts is applied across the bulb, it consumes 0.6 joules of energy per second. It consumes 0.6 watts of power. Question 2b. Show that the voltage across R1 is 2.0 volts and state your reason. So R1's up here is 2.0 volts. The reason is because this makes one complete circuit. So this is 10 volt power supply. There's 8 volts here, assuming it's got a full brightness. So if there's 8 volts there, there must be 2 volts there, because Kirchhoff's voltage law says that the sum of all voltages must add to 0, or all the voltage must be used within a circuit. The circuit could also just simply be redrawn as a single loop. So there's a 10 volt power supply, 8 volts has been lost across light bulb, so that means there must be 2 volts lost across R1, i.e. it's simply 10 minus 2 equals 8, with an explanation being since the bulb A is lit at normal brightness, the voltage across each branch is 8 volts, so R1 must have 2 volts across it. C. Calculate the current through bulb A. Look at our formula sheet. Power equals current times voltage. Since we're looking for the current, we can rearrange that to be I equals power divided by voltage. We know the power 0.6 watts. The voltage across it is 8 volts. Type that into the calculator. 0.6 divided by 8 equals 0.075 amperes.